this particular video, I am going to teach you how to balance the redox reaction. Balancing a redox reaction is very important, and most of the time it is asked in board exam as well as in the entrance exam. So let me explain you how to balance the redox reaction in the easiest way. So first of all, my dear students, you should know how to calculate the oxidation number. So prior knowledge before balancing the redox reaction is you should know how to calculate oxidation number. If you don't know how to calculate oxidation number, so it will be difficult for you to balance the redox reaction. So first of all, learn how to calculate the oxidation number. But that is not part of this video, so we will be focusing on balancing the redox reaction. I assume that you all know how to calculate the oxidation number. So let me explain you. First of all, what we are going to do, we are going to classify the reactions into different types, and based on that I'm going to explain you how to balance those reactions. So let's take first example. So here what you can see over here, so here we have phosphorus, and the oxidation state of phosphorus is 0 over here. For hydrogen it is +1, for nitrogen it is +5, and for oxygen it is -2. Similarly, for hydrogen here we have +1, and for phosphorus we have +5, and here for oxygen -2. For nitrogen we got +4, here -2, and here we have +1 and -2. Now what you can observe over here. So first of all, as a observer, you should know that here what is happening. Here this phosphorus is changing its oxidation state from 0 to +5. It means that it is getting oxidized. And here nitrogen, if you will check, so here oxidation state of nitrogen is changing from +5 to +4. It means that it is getting reduced. So such kind of reactions, we will classify such kind of reaction as type 1. Let's see the second one. So here what you can observe, here we have +2, and here we have +3, and here in case of sulfur, so here oxidation state will be so for oxygen this is -2, and this is 16, here it will be +7, and here we are going to have +6, and here for oxygen -2, and for oxygen -2. So from +7 to +6 change, and here what we can observe from +2 to +3 change. So also we can say that this is also type 1 redox reaction. So let's move ahead and let's see the third example. So here in case of third one, here the oxidation state of carbon is +3. Now the biggest question is, how will you find out this, how will you remember this oxidation state of a particular atom? So if you will practice a lot, then definitely you will remember most of the oxidation state. So because of this reason you need to practice a lot. So here the oxidation state of carbon is going to be +3, and here for oxygen it is -2, for manganese it is +7, for oxygen -2 again, here +1, here +2, here +1, -2, and for carbon here we have +4, and for oxygen here we have -2. I hope up to this point it is clear to you. So here the change in oxidation state of carbon is from +3 to +4, and for manganese it is from +7 to +2. So here one is getting oxidized and one is getting reduced. A reaction in which oxidation and reduction both takes place, so those reactions are called as redox reaction. So this is a kind of that reaction only. So this is your type 1. Now let's look at the second one. So what is happening here in this case? Here in this case what you can observe, here we have copper, so oxidation state is going to be 0, and here again we have copper, so oxidation state is +2. But for nitrogen what is happening? Here we have +5, right? And here in this case what is the oxidation state of nitrogen is? Here in this nitrate ion and in this nitrate ion the oxidation state is going to be same, and here the oxidation state is going to be +2. So the change in oxidation state is from +5 to +2, and also what you can observe, at one point the oxidation state of nitrogen in both the compound is same. So from plus 5 to plus 5 and from plus 5 to plus 4, it means that one particular atom is same in one compound and in another compound it is getting reduced, right. So such kind of reaction you can classify this kind of reaction as type 2. I hope up to this point it is clear to you. Now let us look at this particular reaction. So here what is happening in this particular reaction? So in case of ammonia it is plus 3 and in case of ammonium ion again it is plus 3. But in case of nitrogen what it is? In case of nitrogen it is 0. So what you can observe, from plus 3 to plus 3 and from plus 3 to 0. And also in case of chlorine, here the oxidation state is 0 and here the oxidation state is minus 1. So in one particular element, in one particular atom, what you can observe that it is getting reduced. So also you can classify this particular reaction as type 2. I hope up to this point it is very much clear to you. Now let us look at the next reaction. So first of all we are going to learn how to classify reaction, and based on type of reaction I will teach you how to balance the redox reaction in the simple way. So let us look at the next reaction. So here what is happening? So in case of NaOH and Cl2, what you can observe here, Cl2 oxidation state is 0, but here in this case it is minus 1, and here in this case what it is, in this case here it is plus 5. So from 0 to minus 1 and from 0 to plus 5, it means that in one particular case it is getting reduced and in another part it is getting oxidized, and such kind of reactions are called as disproportionate reaction. So such kind of reactions are called as what? Disproportionate reaction, and you can classify this particular reaction as type 3. Now let us look at the next example. So here we have phosphorus, and in this case what you can observe, it is 0, oxidation state is going to be 0, and then next what you can observe, here it is minus 3, here it is minus 3. So from 0 to minus 3, and here in this case how much it will be, and in this case it is going to be 1. So from 0 to minus 3 and 0 to plus 1. So in one particular part it is getting oxidized, same element is getting oxidized, and in another part it is getting reduced. So this reaction is also a kind of type 3 reaction. So this is also a example of disproportionate reaction. I hope up to this point it is very much clear to you. Similarly, if I move ahead with the next example, so here we have HCl4. So here oxidation state is plus 4, and here it is 0, and here it is plus 6. So in one particular reaction it is getting reduced, and in another one it is getting oxidized. So this is also a example of disproportionate reaction. So it is also a kind of type 3 reaction. Now let us look at the last one. So what is happening in this case? In the last one, what you can observe, here the oxidation state of sulfur is 0, and here the oxidation state of sulfur is plus 6. So what is happening here, the oxidation state of sulfur is plus 4, from 0 to plus 4 and from plus 6 to plus 4. So this is just the reverse of disproportionate reaction, right? So here what is happening, here such kind of reaction, you can call such kind of reaction as type 4 reaction. So we will learn how to balance this type 1, 2, 3, 4 reaction. So first of all, let's try to understand how to balance the type 1 reaction, which is a kind of very simple reaction. So let me explain you. First of all, what you are going to observe, first of all you are going to write down the oxidation state of each and every atom. So let me write it. So for phosphorus it is 0 over here, for hydrogen it is plus 1, for nitrogen it is plus 5, for oxygen it is minus 2, and again here for hydrogen it is plus 1, and for phosphorus it is going to be plus 5, and for oxygen it is minus 2, for nitrogen again plus 4, and for oxygen minus 2, and for hydrogen plus 1 and minus 2. So this is the oxidation number of each and every atom. Now what is happening over here? So for one phosphorus, what you are going to observe? So basically what is happening, this P4 this P4 is getting converted into the H3PO4 phosphoric acid. Now, so one phosphorus has oxidation state 0, and in the another compound what you can observe, the oxidation state of phosphorus is +5. So what is the change? So the total change per phosphorus atom is +5, right? So it means that total 5 electrons are getting exchanged. So for one phosphorus, how many electrons are getting exchanged? You can write 5. And for 4 phosphorus, how many electrons would be exchanged? So you can say total 20 electrons would be changed. So 5 into 4 means total 20 electrons are going to be exchanged. For one nitrogen, what you can observe, for one nitrogen, the oxidation state is changing from +5 to +4. So for one nitrogen, it is just one electron is getting exchanged. But for one HNO3, how many electrons will be exchanged? For one HNO3 molecule, total 1 electron will be exchanged. Now what you need to do? In the next, this is the first step, right? I hope up to this point it is clear to you. In the next step, what you are going to do? In the next step, you have to cross multiply. And what is going to happen? Let me tell you. So you are going to multiply this HNO3 by 20 and this P4 by 1. So total, whatever is the total number of electron which are getting exchanged in this reaction, you are going to do cross multiplication of that number of electrons. So let me do it. So I need to multiply P4 by 1. So I will write it like this. So here I can write it as 1 P4. And for HNO3, what I am going to do? I need to multiply HNO3 by 20. So here I will write 20. So the stoichiometry of P4 is 1 and the stoichiometry of HNO3 will be 20. I hope up to this point it is very much clear to you. In the next step, so what you are going to do? First of all, you need to balance the phosphorus and the nitrogen. So here the key concept is basically to first of all balance those atoms which are critical in balancing this redox reaction. So phosphorus and nitrogen, these two are the atoms which are very important, which are who should be balanced first. So first of all, we are going to balance phosphorus and nitrogen, right? I hope this point is clear to you. So now let's do it. So here we have P4 and on the right hand side what you can observe, we have H3PO4. It means that here I should multiply this H3PO4 by 4. So I will multiply this by 4, right? Now for NO2 we have 20 HNO3. So it means that 20 NO2 should be there, because if 20 nitrogen atoms are present on the left hand side, so 20 nitrogen atoms should be present on right hand side. So I will multiply this NO2 by 20. So this is 4 H3PO4 and 20 NO2. The next step is we need to balance the remaining atoms like oxygen and hydrogen. So first of all, we are going to balance this hydrogen, right? So let's do it. So what you can do over here? So first of all, let's count the total number of nitrogen, phosphorus and whatever is the oxygen, hydrogen, and accordingly we will balance it. If I check the total number of hydrogen on the left hand side, so it is 20 hydrogen we have, but on the right hand side we got only 12 hydrogen. 4 H3, it means that 4 into 3 hydrogen atoms. So total 12 hydrogen atoms are present on the right hand side. So we are lacking 4 hydrogens, right? So already H2 is also present. So total we have here 12 plus 2 hydrogen is also already over here. So we need to add 6 more hydrogens into it. So what we are going to do? So this is your 12. If I will make this 4H2O, so in that case, here we are going to have 12 hydrogen and here we are going to have 8 hydrogen. So it will complete the total number of hydrogen equal on left as well as on the right hand side. I hope up to this point it is very much clear to you. So we have already balanced this one. Now let's count the total number of atoms of hydrogen, oxygen, nitrogen and phosphorus for the confirmation. So let me do it. So on the left hand side total phosphorus atom is 4, and on the right hand side also total phosphorus atoms are 4. On the left hand side the total number of nitrogen atom is 20, on the right hand side it is 20 as well. On the left hand side for oxygen it is 20 into 3, 20 into 3 oxygen means 60 O. So here we have 60 on the left hand side. On the right hand side, so it is 12 oxygen over here and 40 oxygen over here, and so 12 plus 40, and over here we have 4. So how much it will be? So this is 16 over here, and this 4 becomes 20 plus 40, it means 60 oxygen. For hydrogen, so on the left hand side we got 20 hydrogen, on the right hand side we got 20 hydrogen. I hope this is clear to you. Already we have balanced this particular reaction, and I hope it makes sense to you. You can do and find the type, and also you can balance the reaction. I hope this is very much clear to you. Now let's take another example and then we will stop this video, and definitely I will give you a question for the practice. So let's look at the next one. So this is S8 plus HNO3. Here the oxidation state is going to be 0, and here for hydrogen it is 1, for nitrogen it is plus 5, and for oxygen it is minus 2, and for hydrogen it is again plus 1, plus 6, minus 2, again plus 4, minus 2, plus 1, minus 2. So what are the key elements over here? So this sulfur, because the oxidation state of sulfur is changing from S8 from 0 to plus 6, and for nitrogen it is changing from plus 5 to plus 4, and rest of the atoms, in rest of the atom what you can observe, there is no change in the oxidation number. So for 1 sulfur how many electrons are getting exchanged? 6. For 8 sulfur how many electrons will be exchanged? 48. 6 into 8. I hope this is clear to you. For 1 nitrogen how many electrons are getting exchanged? 1. For 1 HNO3 how many electrons will be exchanged? 1. So in the next step we need to cross multiply. So we will do cross multiplication. So for S8 we are going to multiply S8 with 1, and we are going to multiply HNO3 by 48. I hope this is clear to you. Now we will balance the sulfur and nitrogen first, and then we will balance oxygen and hydrogen. So let's balance the sulfur first. So for sulfur here we got S8, so I need to write this as H8H2SO4, and here we have 48 nitrogen. So what I need to do, here we have NO2 only, so I need to write over here 48 NO2, because 48 nitrogen will be 48 nitrogen is present on left hand side, so I need to make 48 nitrogen on the right hand side. In the next step we are going to balance the hydrogen. So let's balance it. So here we have 48 hydrogen on the left hand side, on the right hand side we got 16 hydrogen over here, 8 into 2, and in the next step here we have 2 more hydrogen. So 16 plus 2 we have total 18 hydrogen. So I need to adjust 30 more hydrogen. So what I will do, I will just make this as 16 H2O. So it will make 32 hydrogen. So 32 plus 16. So this is 32 plus 10 42 and plus 6 46. Yeah, now this is your balanced reaction. Now you just need to calculate the total number of atoms, and after doing this you will be able to confirm whether your reaction is currently balanced or not. So let's write down over here. So how many sulfur atoms are present on left hand side? So total 8. And how many sulfurs are present on the right hand side? So total 8. If I talk about nitrogen, so 48 nitrogen, here again we have 48 nitrogen. If I talk about hydrogen, so we have 48 hydrogen this side, and on the right hand side we have 16 plus 32 means 48 hydrogen again. And for oxygen what is going to happen? For oxygen, here we have 48 multiplied by 3 oxygen. So this will become 144. So here we have 144, and on the right hand side, so we have 32 oxygen plus 96 oxygen plus 16 oxygen. So if you will add these numbers, so this will again become 144. So this is 6, 6, 12, and this 2 14, and this 9 plus 3 plus 1 again 14. So 144. So total sulfur, nitrogen, hydrogen, oxygen, all the atoms are equal on left hand side and right hand side. I hope this is clear to you. I am giving you one question as your homework. So what you need to do, you just need to solve this particular question using your brain. So just do it. I hope this will help to you, and in the next video I am going to explain you how to balance the type 2 reaction, and later on I will explain you how to balance type 3, type 4 reaction. I hope this is very much clear to you. Thank you so much for listening. Take care. Bye bye. See you in the next video.